Hello and welcome back to science class. Today we are looking at the Earth, Sun, and Moon. We're going to start off with a simple question. Which of those three does not move? And you get a little hint there if you know what that is. Of those three, which is the one that does not move in our solar system? That's true. If you guessed the sun never moves. The Earth orbits around the sun, and the moon orbits around the Earth. So it also orbits around the sun, but it is orbiting around the Earth as shown by the green arrow. And then the white arrow shows the orbit of the Earth. Now the orbit, we'll find out later, is not a perfect circle like that. And that does affect some parts of our seasons. As I said, we'll talk about a little bit later, but it's important to know that the sun is the center of the universe, so it does not revolve, it does not move within our solar system. But the Earth orbits around the sun, the moon orbits around the Earth, as we can see in this picture here. Now, when I talk about moving with planetary bodies, planets and moons and such, there's two types of movement that we talk about: rotation and revolution. So rotate versus revolve. Sorry, it's a little bit blurry on this slide, but to rotate means to spin or turn, usually around an axis. We talk about the north and south poles. Those are the two axes that the Earth will rotate around. So you can see you can stand up and you can turn in a circle. If you'd like to demonstrate this, feel free. I'm sure no one at home will make fun of you for this. And then to revolve means to go around. So we talk about the Earth revolves around the sun. So it rotates around itself, around the axis. So it rotates in a circle around its axes. That's how it spins. And one rotation of the Earth is 1 day, so 24 hours approximately. But a revolution is how long it takes to go around the sun, and that's 1 year, so 365 days normally, if it's not a leap year. So if you want to revolve, you can pick an object in the room, like a chair, or your couch or whatever is in the middle of your room, and you can circle around it, and that would be a revolution. So it's important to know the difference between a rotation and a revolution. Now again, sorry, it's pretty blurry on this picture. But again, a rotation is how long it takes for the Earth to spin around its axis, and that is approximately 24 hours, or what we call 1 day. And that gives us the day and the night cycle. Now the revolution, the amount of time it takes for it to complete one circle around the sun, is how long a year is. So that's approximately 365 days if it's not a leap year. This leads to our 4 seasons, and we're going to talk about that in a little bit. But we have our 4 seasons depending on where in the rotation the Earth is, and it also has to do with the tilt of the Earth. So what are our 4 seasons? There's another pop quiz. Hopefully you can remember what the 4 seasons are. I'll give you a couple seconds to remember them. If you guessed summer, fall, winter, and spring, you are correct. Those are the 4 seasons. But why do we have those 4 seasons? Well, it has to do again with where the Earth is located in its revolution around the sun in that year cycle, and with the tilt of the Earth. Notice in this picture, we have our 2 axes, the North Pole and the South Pole, but they are not standing straight up. They're kind of tilted. The Earth is tilted in relationship to the sun. So as we spin, different parts of the Earth spend more time tilted towards the sun than other parts depending on the season. So here we have what we call the solstice and equinox parts of the our orbit around the sun, so our revolution around the sun. Let's pick the summer solstice. Summer solstice is the far right one, that's June 22nd. And you can see the continent of North America is faced towards the sun. This is why during the summer we have the longest days. The summer solstice is actually the longest day of the year. And we call it that, meaning it has the same amount of hours, it still has the 24 hours, but we get the most amount of sunlight during the summer solstice. It's not always on June 22nd, but that's approximately around the time that it is, late June. And depending on the tilt of the Earth, you can see that we get more sunlight facing us for more part of the day. So we have the most amount of hours of sunlight. As we go up to September 23rd in this case, we have the autumnal equinox. Autumn is basically another word for fall. So this is the fall equinox. Equinox means that we have about an equal amount of daylight and night and darkness. So there's about 12 hours of sunlight and then 12 hours of darkness. Equinox is another word for half time. And during the fall, we get an equal amount, and you can see below that the vernal equinox. Vernal is another word for spring. So in March, late March, we get the same thing that happens in the spring, which is we get about an equal amount of sunlight and darkness. So equal amount of time where we're facing the sun and we are away from the sun during the day. So about 12 hours of sunlight and 12 hours without sunlight. As we get to winter, is when we get the least amount of sun, and you may notice this when we're going to school, because as you go to school, it'll still be dark out, and it'll start getting dark earlier, sometimes even as early as 5 or 6 o'clock at night, and the sun won't come up until 7 o'clock in the morning. So you get a lot less sunlight during the winter, and that has to do with the fact that we're tilted away from the sun, so we get less sunlight. And this is late December, so right around Christmas time we get the winter solstice, which is the day that we have the least amount of sunlight for the year. So we have the fewest number of hours of sunlight during the winter solstice. So that's how we split up our 4 seasons. Winter we have the least amount of sun, summer we have the most, and then we have fall and autumn where we have about an equal amount of sun. Now we're going to where the moon is. There's 8 different phases of the moon, and we can see 7 of these. One of the ones we don't see is when the moon is what's called empty, where we don't see the moon. That makes the 8th phase. So here are our 2 extreme cases. We have a full moon and we have an empty moon. So the full moon, you may recall, happens about once a month, where we get a full moon, and then another part of the month we'll have an empty moon. In between that, we get our first quarter and our last quarter of moon, where we have about half of the moon showing on one side, and then the last quarter or third quarter we have the opposite end of the moon showing. So why is it that sometimes we see the full moon, sometimes it's empty, sometimes we see half of it, sometimes we see what's called a crescent? Well, and then here's our crescent and our gibbous. Crescent is where we see part of the moon, and it looks, that's on the right side is the crescent. That's where it looks kind of like a sliver of moon. And then on the other side, we see maybe 3/4 of the moon, and it has just one side obscured. That's called gibbous. So why is this happening? Let me skip down to why it's happening first. Well, it has to do with where the moon is in relation to the sun. When the moon is blocking the sun, we don't see it. And that may seem funny because you'd think we would see it if it's directly in front of the sun, but the sun actually, the moon is shadowed by the sunlight. The sunlight moves around the moon and we don't see it because how we see the moon is light reflecting off of it. So if it's directly in front of the sun, there's nowhere for the light to be reflected off of it for us to see it. So as it moves, we start to see a little bit more, and that's what we call the waxing. Waxing is when the moon, think of it going counterclockwise. The moon is starting to get out of the way of the sun, and we start to get what's called a waxing crescent. So we see a little bit of the edge of the moon, but it's still mostly covering the sun from our view. When we get the first quarter, we get about half of the moon. It's still what's called waxing, and we're going to get to that in 1 second, what waxing and waning, the difference is. But it waxes to about half full, we call it the quarter moon. Then it goes to waxing gibbous, where it is closer to 3/4 full or more. So we're getting more and more of the moon being visible until we get a full moon. And the full moon happens when it's on the opposite side of the earth from the sun. We actually get the best view of it. And then we have a waning gibbous. So waning means now it's starting to be less visible to us. Gibbous means there's still more of the moon to see than less shadow. Again, no part of the moon is actually disappearing here. The moon's always staying the same shape and mass, but part of it's starting to get shadowed over. 3/4, about half of it is shadowed. And again, we're still waning. Waning means it's going more and more into shadow until we get to the waning crescent, and then finally into what we call a new moon, where again it is no longer visible in the sky. Now this phase happens about once a month, so don't think of this as happening all in one night. This is a slow process, a gradual process, depending on the relation of the moon in its revolution around the earth and the earth's revolution around the sun. But to get a better idea of what is waning and what's crescent, you can hold up your left hand and make a crescent. So if you hold up your left hand, on that side, that's going to be waning, meaning it's getting smaller and closer to being an empty moon, right? If you have your right hand, if that side of the moon is visible, we call that waxing, and that's going to be growing, or a growing moon. So think of waxing as getting from smaller to more. So less of the moon's visible to more of the moon's visible. Waning, more of it's visible to less of it is visible. And that gibbous is where you see what we call where you can see more than half of the moon is visible. It's gibbous. If less than half of it's visible, that's waning. And then we're going to finish off with just some historical contributions. So these are 4 ancient scholars. So they're people who studied the astronomy, studied the stars and the planets from way long ago. And first we're going to start with in ancient Greece, there was a philosopher and scientist named Aristotle. They didn't even have really telescopes at this time, so they would just look up in the sky with their what's called the naked eye. They would just look up there and they would see the different stars. They would see some of the planets were still visible, and Aristotle believed that the Earth was the center of the universe. This is called a geocentric theory. It's different from what we know now, but again, at the time they had a much more limited understanding of how the universe looked. They could only observe it from where they were standing on the Earth. So when they would look up in the sky, there was less air pollution and light pollution, meaning there weren't the lights that we have, the city lights that we have now that obscure some of it. So much more of the stars were visible. So you were able to see a lot more stars at night than we are able to now. But still, so they were able to see different planets, more planets than we usually see in the sky without the aid of a telescope. But at the same time, they had a much more limited understanding, or much limited understanding of the universe. So they believed that the Earth was the center of the universe and everything revolved around it. So everything orbited around the Earth. So that not only the moon, but all the planets that they could see orbited the Earth. The sun orbited around the Earth. You can see that they believed the sun was actually closer, in between Venus and Mars, which hopefully you know is definitely not the case. We know now that the sun is the center of the universe and the Earth is between Venus and Mars, not the sun. Aristotle was a Greek philosopher. Ptolemy was a Roman philosopher, but he had a similar idea. You could see his sketch of the planets there. He also believed that the Earth was the center of the universe and that the moon and all the planets revolved around the Earth as well as the sun. So he got a lot of his astronomy from Greek philosophers like Aristotle. But then we get a little bit later in time and we get to Copernicus. He believed that the sun was the center of the universe. And he is one of the first people to have a correct theory that we know now of the sun being actually the center of the universe and not the Earth. And at this point, there were telescopes. They were limited, but they did have a better idea of how planets moved, how the Earth moved, and things like that. So they were developing a much better understanding. But it wasn't really until we get to Galileo, who is really considered the founder of our modern astronomy knowledge. Not only did he believe that the sun was the center of the universe, and he was correct about that, but he discovered other planets and moons and other planetary bodies that humans had not known about before. He pioneered many of the advances in the technology of telescopes and our ability to see farther into the universe than we ever had before. So everything that all of our sort of astronomy that science is based on now, most of that was built on things that Galileo sort of discovered and technologies that he developed. All right, so hopefully you made it to the end of this recording. Don't forget to answer the questions below, and I will see you next time. And don't forget to message me with any questions you might have. All right, take care.